Okay, this is the first time I'm going to be doing this with audio. I guess I'm not used to verbalizing my thoughts often, so this will be something new for me. But I guess it'll be useful for, interviews and such. Or whatever, just explain myself. Anyways, I haven't actually done any 2300 rated problems just yet, so should I go with the 2300 rated problem? Yeah, why not? I expect, if I can solve it, that is, it'll take me 2 to 5 hours, I think is reasonable. That's assuming that it doesn't just use a topic that's completely out of left field. In which case, I probably have no chance of solving it, but let's see, which of these problems seems interesting? I don't want to go for a too recent problem either, because then the rating will be super super deflated. Let's see. Well, actually, it might not be that deflated at this level, but who knows? Let's see. Probably something in this sort of area. Anyways, I don't want to do that. Zor seems annoying. Number of groups. I could do that probably. I'm just picking whatever problem looks interesting. Oh yeah, I also don't want to really do a div 3 problem, so I guess I assume that's div 3, or probably not div 4, but who knows. It might just be a special type problem. Anyways, let's see, spent already 2 minutes trying to search for a problem. Let's just go with 3 chairs. I assume this is div. Actually, it might be. I hope it's not div 3. Well, it doesn't matter too much if it is, anyways. I'll do it regardless. And as usual, Codeforces is lacking. Anyways, let's see what the blurb is. Variable with font. Yep. If you're wondering why I'm compiling a solution with nothing in it, every time I compile a solution, it creates a copy of my code and the binary. I guess it comes in handy sometimes, but it's kind of hard to, when you end up compiling things, dozens of times, it becomes a hassle to search for what you're looking for. But I'm really doing it more out of, a data hoarding perspective. If I really want to store stuff, precisely, that's not the right word. If I want to store stuff thoroughly, rigorously, I guess rigorously is as close as to it's getting. Why isn't this loading yet? See, the page loads. Okay, now the page. Okay, finally loads. Let's see what the question is. So, the lowest and the tallest need to be coprime. And what else? And so there can be up to 300,000 friends. There's a good chance this problem uses techniques that I don't know, but I guess we can try regardless. And it's also a single test case for this problem. Like, this trips me up a lot, but I guess, like, I think the polygon rules now state that all problems need to, what's it called? Be like multi-test problems. And see, how old is this? I'm guessing probably 2022. Oh, this will probably take forever to load. 2023. I think the rule came about 2024. Yes. Oh, this is 2023. 3 years ago, but not quite. Anyways, the obvious thing to do is and you obviously want to sort the array to like, yep. So, coprime elements should be, if you pick two arbitrary elements between, two arbitrary integers between 1 and 3, 5, the chance that they're coprime should be, would it be, I think it'd be pretty low, but not that low. Because, well, any prime numbers are automatically coprime. Oh, this will probably require like a sieve type approach. Oh, I wonder if you have to do some type of like ordered set thing, in which case this will be very annoying. Ordered multi-set too. Yeah, not fun. But then again, we don't have to like maintain an ordering. If we just do it the first time, it should be fine. So I guess let's do multi-set. Set. Yep, we want to use an iterator so we actually have a location. Yeah, it's a length and in which case sorting it's kind of superfluous, but I guess we might need it later, so let's just leave it there for now. Set insert. Actually, it doesn't even need to be multi-set, but it doesn't. I don't think it's that much slower to make it a multi-set. I can always just erase multi later. AI. Yep. then it shouldn't be too hard to figure out like the amount of elements in a range. So for each element, we want to figure out how many elements greater than that element. Yeah, how many elements greater than that element are coprime, then subtract 1 from that, because we need to have an intermediate element. No, it's not just subtract 1, it's times their distance minus 1. So that's roughly, I don't know, 600, 500, 600-ish squared. Like, if we know a number is bigger than 600, well, all non-prime numbers will have. Actually, it might be useful to do like a sieve type thing. Get all the primes. Yeah, if there's like, I don't know, 25 primes. Then for each prime, find all the elements that are divisible. I think that would take. I have no idea the time complexity of that, but I guess worth a shot maybe. And then like do some type of query thing. Like, I don't know, I guess I'm gonna just do this right now. Where is OES? OEIS it is. What's the sequence? 26, 30. Yeah, so each one will be like the product of 7 primes or less. So you need to check 7 like disability things, then you just like go off, I guess. It's like it's kind of hard to put these things into words, but I think I have a general idea of how to proceed. So what's the idea? Prime factors of each element. And then some type of weird sum thing that satisfies some properties, but I guess let's start by doing that. So we want to map each vector. Yep, I think that's fine. I don't know how to undo this thing, so I guess, yeah, this appears from time to time. I press some sort of button, and the only way I know how to get rid of it is just to close it. I like this text editor because it can like open very big files quickly, and it generally just works, but it has some annoying features. I mean, it also is very well with font, but I can get rid of that kind of trivially, but I just don't really bother to. Anyways, let's see. I would do. Yeah, why not? This is probably a bad habit of mine, but I mean, it works. Yep, so what's the time limit? Only 1 second, so I might end up having to cut back a bit, but should be fine, hopefully. 4. Oh, I want to have like a temporary variable. We'll just see that. I think like reuse variable or something. Yeah, did not. I probably should write like a real function for this sometime, but not really necessary right now anyways. I don't want a second iterator. Let's see. Yeah, I mean, this is doubling up on double up, but let's see, where is this? Comparative programming. Where's my... I didn't bring the thingy. Oh, that's annoying. I thought I brought the reference code. Maybe it's in... Oh, it's gotta be one of... No, I'll just write its prime function by hand, I guess. For t equals 2, t is less than or equal to n times t times t is less than or equal to n. No, I think this works, like, I guess there's an easy way to test this. And let's do a composite one for good measure. Yeah, I'm really taking things slowly, but it's not a contest, so now let's see. Is that right? Prime, not prime, not prime, not prime. Yep. Oh, that works. Oh, let's see. Yeah. While t is not equal to I, 2 1 that is. If is prime. Yeah, this isn't really print matrix, but I guess I can use that. It works. PFSI. I'm assuming the compiler will optimize this to t equals 1. At least I hope so. Where did I get wrong? Yeah, there. So I'm taking this slowly, I may as well check. Does the compiler actually... Actually, I can't really be bothered. Because, like, it should throw an error if t equals 0, but I don't know if it's, like, considered undefined behavior. Or if it's just, like, this little branch thingy or whatever. And then just iterate upwards. Yeah, and you only want one prime factor of this too. Actually, do we? Yeah, we only want one. Oh, yeah, this will terminate eventually, so. While yeah, I think this should work. And then I guess let's just test it out. Please, yeah, print matrix of PFS. And it sorts stuff too, so anyways, let's just see what it does with this. Did I do something wrong? That is 7, right? T equals AI. But yeah, obviously this needs to break as well. Ugh. Still not working. Oh yeah. Intriguing. Just when in doubt, debug lazily. So it's not reaching that point, I don't know. I mean, oh yeah, that's why. This needs to... Silly me. I'll just copy this test case. Nothing 3. Yeah, it's right. 27, 37. Seems right to me. Oh, these are actually multiples of 6, 7, 3. Yeah, one thing I don't understand is why people don't do this, like define solve above, then define this actual solve function below main. Like, I like having extra, like, vertical space to work with. Anyways, now we have the prime factors. For each prime, we probably want to index of, like, which elements divide that prime. Because that's like kind of like the break point, if you feel me. Yeah, it's really a lot slower trying to commentate this. Map LL. Oh yeah, I don't know why people didn't do like capital L's as well. Just say PDIs. Indexes. Yeah, it's faster to make this a vector, actually. Vector. And then it's like 3, 5, so yeah, let's just do a million. PDI dot wasteful. It doesn't even let you do this. Yeah, P. Do that first, but it actually works. Okay, now we get to consider the mystical world of magic. But this could be a pain for to actually use like the principle of inclusion and exclusion. I really don't want to do that. Yeah, this will take a while. I need to actually do schoolwork as well, so I'll probably cut this at 90 minutes. Ugh. So, we want to find, like, if we have a set, let's just say set A, and a set B, you want to efficiently but they can like intersect at ON. Points. Maybe if you just like collect all the elements. See which ones are co-prime with other elements, but can you do that efficiently? Yeah, I'm guessing This question requires some type of obscure number theory I have no idea about, in which case I don't have much of a chance of solving it, but let's see. So for like each prime, 2, 3, 5, 7, etc. Iterating down that path. Actually, how many finite combinations would there be? There wouldn't be that many, actually. Yeah, there wouldn't actually be that many finite combinations. Oh, let's do the test. One more. Ugh. Easy way to do this is, let's see. Oh. Yeah, we're not going to do this right now. We're just going to set n equals. I don't think I use this. Well, we're going to delete this anyway, so it doesn't really matter. A or pushback. Let's see if this actually works. Nope. What did I do wrong? Where's this not how you're supposed to do it? We'll just see if... Oh yeah, it's supposed to be print matrix. What's getting hung up on? wouldn't be getting hung up on that, would it? It would. Annoying. Oh yeah, this needs to be. Yep. And let's see how many combinations of these are there actually. It's gotta be one for each prime. Won't be many elements divisible by like the higher primes. Yeah, we want to make PFS a set, so. I hope this works. Let's see. Probably won't. Yeah, it needs to be at least one. Okay, that's... Lord, how many large primes are there? Yeah, I'm really lost. I really don't think I'll be able to solve this. Number theory is not my strength, even though I'm supposedly a math major. So, you know, for each prime we have a list of elements that prime is divisible at. That is only guaranteed to be pretty large in certain cases. But when it's large, what do you do? I mean, if you consider all the ones that are divisible by 2, and then you just like go up and subtract all of them. Then you consider all the ones that are divisible by 3. Not 2. No, 3 and then... Yeah, who knows if that works. We'll just try to like write this in terms of a function. So with a sorted list, we want the sum from I equals 1 to n of AI the sum of j equals I plus 1, I plus 2, doesn't really matter, let's just put j equals I plus 2 to n j minus I minus 1 if GCD I j equals 1. Maybe if I just search up counting GCD. Maybe it's on the top list. This being number theory. this could be kind of what I want. I forgot what the totient function is. Oh, this is, is there, did I miss some sort of constraint? The height of each friend is unique. I guess that doesn't really change anything, but... Oh. or is there some type of like easy solution I'm missing? I suppose I've kind of convinced myself that this is using something I don't know yet, so subconsciously I'm probably overlooking. Well, probably it does use something I don't know yet, but in like, I don't know, it's 30% chance it doesn't. I'm overlooking the obvious answer. Well, it's still probably not an obvious answer. See what other, what's this? Doesn't really matter that. Got a message, so I'll pause this for now. Okay, this is the first time I've tried unpausing. Let's see how this goes. I think it probably has something to do with other this or that. some what's this? Sum of all. Yeah, no chance I'm solving this. I would have solved it that well. I'm stumbling over my words, aren't I? What's the time complexity of this? That is, if this even is the right path. This mentioned here, number theory. Is there an expand all button? GCD, convolution, medium decay. Is this? Yeah, mod is not required, but I mean, this will always be below that much. So, well, I guess now I just need to figure out a way to convert this formula to like a representation of this. So the problem is like the triangle. How do I get rid of the triangle? Ugh. Is that even what I want? Because I want the GCD of the elements. Might be a way to like convert it somehow. But I think this is on the right track for what I want to do. I guess I'll stop it for now. I mean, probably don't want to spend too much time on the same problem. Well, I mean, like, too much time in one continuous block of time. And I do have other stuff to do, so I think this is an okay start. Like, I have somewhat of an idea of what I have to do. Well, somewhat of an idea of one possible way. I guess, yeah, I'll leave it here for now.